we begin? That means
Yes.
everybody, okay.
So you handed to the GA, right? How is it the email? You email the GA?
For the assignments?
Yeah.
Yeah. I think I put the information on the website where you have to email. I think the email was something like CS440 fall 2015 at yahoo.com. And you'll zip your project, also create a small Word document with some screenshots.
Yeah, how do we show the information when we create an object? To the console or?
Oh, for this one, you know, it's the final UML that's more important.
Okay.
So you don't have to
Do
worry
anything.
about
Okay.
any object creation.
Okay.
All right, so looking at the object-oriented programming fundamentals, right? So encapsulation, which is creating the classes, the private, public, protected declarations. Okay, so creating a class. Okay, and the private, public, protected keywords. Okay, that was our encapsulation mechanism. Then we discussed inheritance. Okay, so here we create some base class. From here we can inherit another class or more than one class, right? Okay, so remember, you do not create the base class first. First you create the actual classes that represent the physical things in your system, and as you create those classes, you take a look at the common things that are appearing, and whatever things you are duplicating, you'll take those common things and move them into the base class. Okay. So this is called the base class, this is called the derived class. Okay, and sometimes people call this the parent class or the child class. Okay, it doesn't matter, right? Okay, so through the university application, hopefully you guys have gotten a good idea of this. And once we use inheritance, we run into keywords like abstract, override, and virtual, correct? Okay, so if this is the top level base class, and if there's a code that exists in the method, then how will that method be marked if we wanted to allow this to be overridden in the derived class? Virtual. If this is the top level class and there's no code over here, so just a declaration of the function, what inputs it takes, what output it gives, then how will it be marked? Abstract, right? Okay, so regardless it's abstract or virtual over here, if we override it and provide our own code over here, can we further override it from here?
Yes.
Yes. So from an override, you can further change the code over here, and we can do another override, right? Okay, so those were the key concepts that we ran into once discussing inheritance. Okay, and last lecture we were looking at polymorphism, which is the third fundamental concept in object-oriented programming. And polymorphism, as we discussed in the last lecture, poly means many. Morphism basically means forms. So in terms of programming, think of it as many forms of a function. Or in other words, a function or many functions with the same name. So many functions with same name. Okay, so as we discussed, polymorphism can occur in two different scenarios. One was a very simple scenario So one is within the same class. So within the same class. Okay. Now this is a very easy form, and a lot of people do not consider this to be the true polymorphism. But if we strictly go by the definition of many forms of a function, it could be qualified as one form of polymorphism. So this is called method overloading, right? Okay, so again, the idea was if you created some class, let's say XYZ, okay, suppose you created some function in it, public, double, let's say compute something, int A, int B, right? And you wrote some code in it, whatever that code is. Okay, so the question is, can we write one more method over here, which is also called compute? Okay, and the answer is yes, we can do that, as long as either the number or the type of parameters is different. Okay, so for example, what if I did this, float A, float B? Will this be allowed?
Yes.
Yes, because the type of the parameters is different. Okay, so remember the rule in overloading was we can overload a method as many times as long as either the type or number of parameters is different. Right? So this was the rule in overloading. So these two are perfectly okay, correct? So what if I do this? So instead of second being float A, float B, I also do int A, int B, and add a third parameter, int C. Will this be okay? Can both of them exist in the same class?
Yes.
The answer is yes, because now it has 3 parameters. This only has 2 parameters, right? So that's perfectly okay. What if I do this? Leave these as 2 parameters, int x, int y.
No.
I change the name of the parameter.
No.
No, because see, it doesn't matter what name we give it. The data type is the important. It's int. So 2 parameters, both are int, so this will not be allowed, right? Okay, what if we do this? We make it int x, int y, but the return is, let's say, int, rather than double.
No.
Yes or no?
No.
And the answer is no. Take a look over here. We don't talk about the return type, only the parameters. So if there are 2 parameters, both are int, this will not be allowed. Okay. So anyway, that's called the overloading. Okay. And as you already know, we often overload constructors. Because remember, constructor is like a method, right? Okay, so that was the easy form of polymorphism. Now let's take a look at the tricky form of polymorphism, or the more useful form of polymorphism, and that occurs when we are between a base and a derived class. Okay, and this is called overriding, basically. So it occurs whenever we run into overriding. Okay. So now the key concept to remember over here was number 1, okay, base class reference can point to a derived class object. So this is true not just C# but all object-oriented programming languages. So all OO languages allow this concept. Okay? Without this concept, we won't be able to create sophisticated programs where we have many classes and some relationships between those classes, right? Okay, now coming to polymorphism, what it means over here is, so first let me describe it in plain English, then I'll give you examples. So in plain English, the polymorphism, so this polymorphism over here occurs like this. If a base class reference is used to point to a derived class object, just write it to a derived class object, then the call to a method from the base class reference should execute correctly. So that's the goal of the polymorphism. So if we are using a base class reference to point to a derived class object, then the call to a method from the base class reference should execute correctly. Okay, so what do we mean by correct execution? Let's pick an example. Okay, so suppose we created a class called student. Okay, and suppose we had public string compute grade. Okay, and we had some kind of a formula, AVG equal to 0.4 times test 1 plus 0.6 times test 2. Okay, and we said if AVG is greater than 90, okay, grade equal to 8, and so on. Okay, so in a student class, we had a compute grade method which gives 40% of the weight to the test 1 and 60% of the weight to test 2, right? Now let's go create a class called grad student.